Honda EHEV. Everyone talks about the battery. Won't the pack die? Aren't hybrids time bombs after 100,000 miles? But if you look at how these systems actually work, the Accord hybrid, CR-V hybrid, Civic hybrid, and Jazz and Fit hybrid, the high-voltage battery is usually not the first thing that kills them. There are other, more boring, more preventable things that will quietly end an EHEV's life long before the pack gives up. I'm GearHead. This is the Forensic Breakdown, the 5 things that will actually kill a Honda EHEV, and it's not the battery. Make sure you're subscribed. By the end of this, you'll understand Honda's hybrid system better than most service advisors, and you'll know exactly where long-term risk really lives. First, a quick 10-second recap of how EHEV actually works, because this matters for understanding what can go wrong. Honda EHEV uses a 2-liter or similar Atkinson cycle gasoline engine, a generator motor bolted to the engine, a drive motor connected to the wheels, a single fixed-ratio gear and clutch that can link the engine to the wheels directly, and a high-voltage battery pack. There are 3 main modes. 1. EV drive. The battery powers the drive motor, which powers the wheels. The engine is off. 2. Hybrid drive, or series mode. The engine spins the generator, producing electricity for the drive motor, which powers the wheels. The engine is not mechanically connected to the wheels. 3. Engine drive, or direct mode. At higher steady speeds, a clutch engages and the engine drives the wheels through a fixed gear, with the motor assisting or regenerating. So most of the time around town, you're effectively in series hybrid mode. The internal combustion engine is a generator, and the electric motor does the driving. On the highway, you switch to direct mechanical drive for efficiency. With that in mind, let's look at what really kills these systems. Number 1, coolant neglect, especially for power electronics. Fact: electronics hate heat more than almost anything. In the EHEV, you've got an inverter that controls both motors, power modules switching high currents thousands of times per second, a DC to DC converter stepping down pack voltage to 12 volts, and a cooling system designed to keep all that just below its stress limit. Honda uses liquid coolant for its hybrid electronics. There's an engine cooling loop and coolant paths through or around the inverter and power modules. If that coolant is never changed and loses corrosion protection, gets air in the system after a poor bleed, or leaks and runs low, you can end up with hot spots in the inverter, reduced cooling flow, and progressive thermal damage to the IGBTs, MOSFETs, and capacitors. The failure chain looks like this. Cheap coolant or neglect leads to micro-corrosion or scaling in passages. This causes slight flow restriction or local boiling, leading to repeated over-temp events under heavy motor load. Finally, the inverter fails, you get a check hybrid system warning, and the car derates or quits. Most owners never think of inverter coolant as something real, but in the EHEV, once the power electronics go, you've taken down the heart of the hybrid system. What to actually do? Follow or mildly beat Honda's coolant change intervals, especially if you tow or drive in hot climates. After any cooling system work, make sure the hybrid loop is bled correctly, no trapped air, and don't ignore any hybrid system warning, especially under high load or hot day scenarios. Fun fact: power electronics can often survive hundreds of thousands of miles in industrial settings if cooled well. They die early in cars mostly because people treat coolant like it's immortal. Number 2, oil neglect and fuel dilution in the engine. Even though EHEV engines live easier lives than high-boost turbos, they're still internal combustion engines. They need proper oil and proper change intervals. The reality is that hybrids are uniquely vulnerable to oil quality issues because of how they start and stop. In the EHEV, the engine doesn't run all the time. It fires up when needed, often from warm but not fully hot. Short city trips with lots of EV operation mean more frequent cool starts, less time at full oil temp, and condensation and fuel traces that don't always get fully burned off.
If you stretch oil intervals far beyond what makes sense for your use cheap oil or wrong spec oil, or drive mostly short trips in a cold climate, you're setting up sludge formation, thicker cold oil that flows poorly at each restart, wear on cam lobes, lifters, and timing components, and potential low-speed pre-ignition or detonation if dilution is bad enough under load. Many people assume it's a Honda hybrid. The engine doesn't work that hard. I can go long on oil changes. That's backwards. EHEV engines might need good oil just as much, maybe more, because they're Atkinson cycle, meaning longer expansion and hotter exhaust at times. They change operating modes often between series and direct, and they see a ton of start and stop cycles in their lifetime. What to actually do? Use exactly the oil grade and spec Honda calls for, which is 0W20 full synthetic in most EHEV applications. If your driving is mostly short trips, ignore the max interval and change it sooner. Time matters as much as miles. Don't rely only on maintenance minder percentages if your use is atypical, like all city driving or cold weather. Engines don't usually explode in hybrids, they just slowly lose compression and start burning oil after years of low-grade neglect. Once that happens, the hybrid system can't save a tired internal combustion engine. Number 3. Heat-soaked motor windings and bearings. This happens when cooling fails twice. The hybrid drive motor in an EHEV does most of the driving at low and mid speeds. It handles torque that in a conventional car would go through gears and a torque converter, and it spins at high RPM under heavy load on hills and during highway assists. It is cooled by liquid coolant in most designs, conduction through cases to surrounding metal, and airflow around the motor assembly. If the coolant isn't maintained or the system is pushed hard in hot climates, towing, or steep grades with marginal cooling, then over many years, motor windings can run hotter than designed. Insulation ages faster through thermal degradation, and bearings see persistently high temps and loads. This doesn't show up at 20,000 or 50,000 miles. It shows up at 120,000, 150,000, or 200,000 plus miles. It presents as increased electrical noise, higher losses, possible high-voltage leakage detection, and in the worst case, traction motor failure. Is this common? Not yet. The EHEV hasn't been out long enough in huge fleets to give us thousands of 300,000-mile data
But from
points.
an engineering standpoint, the risk factor is clear. A motor designed for life at 90 degrees Celsius average won't survive the same number of hours at 120 degrees Celsius average. If the hybrid cooling loop is always marginal, the EHEV's drive motor and generator motor are eating into their life budget faster. What to actually do? Treat hybrid cooling as critical. Don't tow heavy or climb long grades in extreme heat while ignoring warning signs. If you ever get overheat-related hybrid warnings, don't just clear them and keep going. You don't want to be in the first wave of EHEV motor failed at 180,000 owners because of accumulated heat abuse. Number 4. Transmission clutch abuse in engine drive mode. One of the most interesting and under-discussed parts of the EHEV is the clutch that enables direct engine drive. Remember, in EV and series hybrid mode, the engine is not connected to the wheels. At higher steady speeds, the EHEV engages a clutch that links the engine to a fixed gear to the wheels. That clutch has to smoothly engage at highway speed, handle torque transfer without slip or harshness, and deal with real-world driving like hills, passing, and partial loads. Mechanically, that means friction material, heat from engagement, and wear if abused or calibrated poorly. If a driver constantly forces heavy acceleration right as the clutch engages, lives in hilly terrain with constant mode switching, or if the software calibration in early generations is a little aggressive, you can see over a very long period extra clutch wear, possible shudder or slip under load in engine drive mode, and the need for a transaxle or clutch repair much sooner than lifetime expectations. So far, Honda's calibration has been good. There's not a wave of EHEE clutch failures, but this is an area to watch as high mileage examples stack up. What to actually do? Don't manually force gear or range changes that fight the hybrid logic in regions with manual modes. Avoid hammering the throttle right when the car is transitioning to engine drive. You can feel the mode change in some cars. If you ever feel persistent shudder or slip at a specific speed or load, get it checked early, not after it cooks itself. As with any clutch, smooth use equals long life. You don't have a pedal, but the software is doing that job, and abuse still shows up in heat and wear. Number 5. Chassis rust and neglected, boring parts that outlive the hype. This is the unsexy one, and it kills more good hybrids than any battery or inverter ever will. A Honda EHEV car can die in practice from rusted subframes, rotted brake lines, corroded suspension pickup points, completely shot bushings, struts, and mounts, and the exhaust falling apart long before the EHEV hybrid system is worn out. This is especially true in snow and salt regions, coastal areas, countries with poor underbody protection, and cars that never get washed underneath. The reality is that you can have a perfect engine, motors, and battery at 180,000 miles, but if the structure is rotting and the suspension is trashed, the car becomes uneconomical to keep. Honda is not the worst in the industry for rust, but they're not magically immune either. And owners tend to obsess over, is the battery okay, while completely ignoring the corroding hard brake lines and subframe wells. What to actually do? At least once a year, or twice if you're in heavy salt, get the car on a lift. Inspect the rear and front subframes, brake and fuel hard lines, weld seams, drain holes, and suspension arms and bushings. Treat surface rust early before it becomes perforation. Replace tired suspension components before they ruin other parts like mounts and tires. No hybrid system survives a rotten body. That's not a Honda problem, that's a physics problem. So, is the Honda EHEV reliable? From what we know up to 2026, yes. If you respect hybrid cooling, you don't treat oil changes like a suggestion, you allow the system to work as designed by not fighting modes or constantly abusing it hot and overloaded, and you treat the car like a 200,000-mile candidate, not a 5-year lease toy. The 5 things most likely to hurt a Honda EHEV long before the battery are 1. Cooling neglect leading to inverter and motor heat stress. 2. Oil neglect and short trip use leading to slow engine wear. 3. Chronic thermal overload leading to motor insulation and bearing fatigue. 4. Harsh or abnormal driving in engine drive mode leading to clutch wear. 5. Rust and chassis disintegration killing a perfectly good drivetrain. And the battery? With Honda's conservative management and typical hybrid use patterns, it's usually fine beyond what most owners keep the car for. When packs do eventually age, they often do so gradually, not catastrophically, and usually well before other issues could have been prevented. If you want a deeper forensic look at hybrid systems, Toyota versus Honda versus BYD versus Hyundai and Kia, and exactly how to inspect the weak spots yourself, make sure you're subscribed. I'm GearHead. Every hybrid has a story. And together, we're going to make sure your Honda EHEV doesn't end early for reasons that had nothing to do with the battery.